Hello, everyone, and welcome. We're taking a look at our next lesson, which is lesson 3.5, and it's called Better Weather. So we're going to be talking about comparing and contrasting data with box plots. So we see this first slide that says Mia lives in Seattle, Washington, and her best friend Bo lives in Charleston, South Carolina. So they're debating whose city has better weather. How could they compare the weather in Seattle and in Charleston? So you're just going to think of an idea. What could they do to compare this weather? Take a moment, answer that in the box, and then push ahead to slide 2. On slide 2, it says rainy days. Mia and Bo wondered which city has rainier weather. So Mia made a dot plot of the number of rainy days in each month in Seattle in 2021. What is the greatest number of rainy days in a month? So if we look at the graph, it looks like we have 2 dots here for 6. So 2 months had 6 rainy days. Seems like the greatest number. Greatest number of rainy days in a month. Oh, nope, that's wrong. The greatest number of rainy days is here, which is between 22 and 24. It looks like 23. And what was the fewest number of rainy days in a month, which is this dot here between 0 and 2, which is a data point for 1. So 1 month there were 23 rainy days, and another month there was only 1. Beautiful. Let's look at the next slide. So a Desmos graphing calculator. So over on the left in the hold on a second. There we go. Okay. On the left side it says here is the same dot plot showing the number of rainy days in Seattle in 2021 for each month. Look at the statistics in row 5. Statistics is a single number that measures something about a data set. So what do you think each of these statistics tell us? So you can notice in row 4 we have all of the numbers, 18, 16, 12. These are all the different numbers of amount of rainy days in a month. And then we see the stats. We have a minimum, quartile 1, the median, quartile 3, and the maximum. And we made this dot plot. So the minimum is the lowest number of days. So our minimum is 1. There's our point for 1. While the maximum is the most, which is here, which is 23. Our median is the middle value. So the middle of the graph is about 10. It doesn't have to be an exact data point, but that's where like the middle of the values are. And then we have Q1, which is 5.5 here, and that's like the middle of the left side. And Q3 is 17, which is here, and that's the middle of the right side. So this is called our 5-number summary. When we're working in dot plots, these are the 5 numbers that you will calculate to make a dot plot. So let's push ahead to slide 4. The 5 statistics on the previous screen split the data into quarters, which are called quartiles. Now, when we think of quarters, remember a quarter is 25 cents, and there's 4 quarters in a dollar. So we have quartile 1, quartile 2, 3, and 4. Just like if we think about throughout a school year, right? We have 4 quarters. That root word, Q-A-R-T, quart, means 4. So if I hit play, if we take those values and make a little box, this is a box plot. So we grabbed the minimum value, the maximum value, our middle value, and then our Q1 and Q3. And what this does is it makes 4 sections, right? Here's our first quartile, second section, third section, and fourth. So we use these 5 numbers to create our 4 quartiles. Beautiful. If they're all a quartile, right, each of these are 25% of the data, right? A quarter is 25 cents. So each of these parts is 25%. Beautiful. Let's look at slide 5. Here's the dot plot for the number of rainy days each month in Charleston. So Bo says that in half of the months of the year, Charleston had at least 6 rainy days. So half of all the data had, at least 6. So over here, this is half of the data, right? 25 plus 25% is 50%. Half the data had more than 6 days of rain. How can the box plot help you see that it's true? We can see that our middle value is literally at 6. So to the right of 6 is half of the data. To the left of 6 is half of the data. So we could also say half of the months of the year had less than 6 rainy days. We can say the most amount of rainy days a month had looks like 11, and the least amount of rainy days is 1. There may be many more data points that you can, okay, so if you show the movable line, you can drag it to find the exact values, so you can see what those different values are, and you can drag it. Cool. So yeah, our maximum's 11, minimum is 1. We have the middle at 6. So we can see what's going on with this data here. Here's 2 examples. There's many more things that we could pull out of this data. So pull whatever feels good to you, and then push to slide 6. Here are 2 box plots showing the number of rainy days in Seattle and in Charleston for each month in 2021. Use the box plots to help Bo convince Mia that Seattle is rainier. So we can see that the this whole portion of Seattle is much more rainy days than Charleston, right? We can see that the median is also higher. So the median in Seattle is 10, while the median in Charleston is 6. This makes Seattle rainier. We also see the maximum number of rainy days is 23 for Seattle versus 11 for Charleston. Also makes Seattle much rainier. We can see also that 50% of the rainy days are more than 10 in Seattle. So just a bunch of different answers that we can see to show by looking at these 2 box plots how we can compare these 2 different data sets. Beautiful. Let's look at slide 7. Mia and Bo also wondered about which city is hotter. So we can see that Seattle gets more rain. Let's think about the temperature now. So what are the high temperatures in Seattle for each day of 2021? So which representation do you prefer for making sense of this data? So this is a dot plot. We can see the data, how it increases. We can see where those high values are, or we see the box plot. Both of these are giving the same information, but you may like one more than the other. So the dot plot might be better. The dot plot gives a sense of each data point and you can see where it grows and the shape of the data. And the box plot, if you were to choose that, the box plot helps with seeing the percentages of data and how it is distributed, right? We can see that 50% of the time it is more than 60 degrees. We can think about percentages in that way, which can be really helpful with box plots. So whether you choose dot plot or box plot, it's your liking which one you prefer. There's no right or wrong answer here. But when you're ready, we're going to go to slide 8. It says making a box plot. So the data, I'm going to zoom in over here so we can read this together. The data sets for the high temperature for Seattle are S and Charleston are C. So here's our Seattle and here's our Charleston. In row 7, look at how to create a box plot for the Seattle data. And in row 8, we're going to create one for the Charleston data. So in row 7, we just typed in box plot and we put S in parentheses to make the box plot for S Seattle. So I could do the same, but box plot for C. Offset 3, height 1, I'm going to keep them the same. Well, actually I'm going to, let's see. Okay, so if I move over, here is our 2 box plots. So we can click them to look at one compared to the other, like that. Beautiful. I'm not sure what offset means. I'll have to figure that out. I'll look into that. But yeah, we can see here that the temperature of blue, our blue box plot, goes much further than our Charleston. It's hard. I want to be able to like lift one up. What if I make this 5? Aha! There we go. Okay. So if you do offset, it lifts it up. So now we can see them next to each other. That's helpful. So we can see that 50%, well, actually like almost 75% of the time it's warmer in Charleston than it is 75% of the time it's like 70 or below, versus in Charleston it's 70 above most of the time. So that gives us some good information about the temperature. We can also compare the medians. Like on average in Charleston, it's about 80 degrees. On average in Seattle, it's about 60. Big difference there. Beautiful. Let's look at slide 9 next. So it says here are 2 box plots for the high temperatures in Seattle and Charleston. What is the median for each data? So if we grab that movable bar, let's bring it over to Seattle. Looks like the Seattle's median is 60. And if we bring it over to Charleston, the median is in the middle. That is 79. So we have 60 and 79 for our 2 medians. Perfect. Next slide. Here are box plots from the previous screen. Select all the true statements. Seattle had at least one day over 100. So 100, yeah, it must have been because our maximum is 104. So it had to have been over 100. Charleston had exactly 25 days with a high temperature over 87. So 87 is here. We don't know exactly how many of those days. 25% of the days were over 87, but it's not 25 specific days. And then for about half the days, Seattle's high temperature was between 50 here and 72. Yeah, that looks good because this is 50% of our data because it's 2 quartiles. So about half the data is between 50 and 72. Okay, I'm going to have to pause the video, but finish these last couple slides up and then make sure you're submitting into Schoology. You got this.